Page 6 of our Chapter 5 review. Okay, so this problem number 22, we're going to have to draw a picture that fits the description. Okay, so in an isosceles triangle, the legs are the congruent sides. So if they tell you one of the legs is 17, they're both 17. The base is the other side that might be different. In this case, it is. No, it's 12. Okay, this is different. We're going to have to draw in our own altitude from the vertex angle up here to the base. Okay, that's going to split the 12 into two equal parts, 6 and 6. Now, this is only a guarantee because it's an isosceles triangle. Okay, so we could actually prove that these two triangles are the same. These two halves are the same by HL if we needed to, but we don't. So now what we're going to do is we're going to take each of these smaller triangles, and I'm going to use this one. I'm going to use Pythagorean theorem on the smaller one to calculate the length of the altitude, the height of the altitude. Now, we got to be really careful. The 17 is the hypotenuse, so make sure it's on one side by itself. A and the 6 are the legs, so square both of those added together will hopefully come out to the same as the 17 squared, hypotenuse squared. Okay, it does say to round. Nearest tenth means round. So when we take the square root of 253, we get just under 16. Okay, for 27, when I plotted it, I noticed it was isosceles. Okay, so in an isosceles triangle, when we draw any one of the four special segments from the vertex angle, A is the vertex angle, we're going to get all four of them. So what I noticed first was D was the midpoint of BC. So that makes it the median right away. I can't prove angle bisector other than in this case. Okay, the only reason that I can show it's angle bisector is because AC is the same as AB. Now, I don't believe that it was intended for me to have to prove that, but I just went ahead and did that anyway. So I start out by saying I know AC is the same as AB, and since D is the midpoint of BC, it's the median. Now, I went ahead and I proved that it was isosceles because I didn't feel good about just saying it was. Okay, so I proved that they were. So the median from A, which is the vertex angle, to the CB, happens to also make it the angle bisector, altitude, and perpendicular bisector. So all four. All right, 28, last one. So this is that mid-segment, the three mid-segments of a triangle. Create this smaller triangle inside that has a perimeter that's half of the big one. And you can see it's a quarter of the area. We've talked about that before. In this case, they really just want to apply that perimeter mid-segments equal to half the side it's parallel to concept. So that's what I'm doing right now. They told me that PQ is 20, so I immediately said these are all 10s. So I know UT is the mid-segment that is related to side PQ because they're parallel. So if that's 20, that's 10. I could also do that here. This SU is 13, so I could, if I needed it, QR would be 26, but I don't need it. What I'm doing right now is I'm utilizing the three sides in this small triangle are supposed to add to 35. That's a perimeter. I'm choosing to do it algebraically. You don't have to. You could just say 13 plus 10 is 23. 35 minus 23 is 12. So I'm just getting 12 algebraically, not necessary. Okay, if this one's 12, it's parallel to this side, so you double the mid-segment to get the side that it's parallel to, so it's 24. And that's it for the Chapter 5 review.